And we are live. Welcome, everyone. My name is Daniel. It's Tech Excellence, and I would say let's get started. Yeah, who we are, Tech Excellence. Our vision is to raise the bar of technical excellence across the world. Here are our organizers. First and foremost, Valentina Cupac, our founder and organizer. We have next to her, we have Alina Liburkina, another co-organizer, and Oliver Ziller. And last but not least, Daniel Moka, me, the main host of today. Yeah, here you can see our speakers from the past. The good thing is that all of the sessions have been recorded and so they are available on YouTube. I recommend everyone to check them out. There were some really exciting sessions, a lot to learn from. And here are our speakers for today and for the future as well. So stay tuned. There, as you see on the picture, there will be some really good and interesting sessions in the future. Yeah, we are available on a lot of social media platforms and online, of course, Tech Excellence IO, or main website. You can follow us on Meetup, YouTube, LinkedIn, Twitter, or X in other name. We have a GitHub, and last but not least, we have a Discord channel where everyone is free to join for free. So if you want to ask some question about technical excellence or about anything related to crafting quality software, you can join there and we can talk about this. So big thanks to our sponsors, Optivem, and to our partners, QE Unit. Yeah, Tech Excellence, learn how to deliver quality software faster. And let me introduce you the speaker of today, who is Igor Sosman. He is a senior software architect at Schott Pharmaceutical Packaging. He has more than 25 years of experience in software architecture and development. He's designing, advocating, and implementing effective architectures for sophisticated machine learning-based systems and enterprise applications. He has a strong interest in Java and domain-driven design, which leads to the topic of today, domain-driven project structure, how to write maintainable code. Igor, welcome.
Hi, thank you.
Welcome. I would say the microphone is yours, but before I hand it over, I would like to let the audience know that if you have any question during the session, that feel free to ask it in a YouTube chat section, and at the end of the presentation, Igor will be happy to answer all of those. So basically, that's it. Igor, I wish you good luck. We are super excited, and yeah, the microphone is yours.
Yeah, thank you very much. So let's start with the presentation. Today we're going to talk about domain-driven project structure, and the main goal is to understand how to write a maintainable code, because we know a lot about theoretical topics. So we all know about domain-driven design as a paradigm, and we know about different types of architecture, but how to organize the code, it's always a bit of a problem. So what do we plan? Introduction, just roughly 2 minutes. Then I go from domain-driven design to project structure in 3 minutes. And we will start with a very interesting, from my point of view, interactive live coding for 64 minutes. You may ask why 64 minutes? Because we love round numbers. And after that, we can go into question and answers. About myself, I can skip this part already. And then, so you probably know this so-called blue book about domain-driven design. But this is very much about the concept. And from the concept, we would like to go to implementation. Implementation, right, we have a lot of different types of architectures. We have onion, clean, and this looks a little bit messy, but how can we go and write a sustainable code? Because you know that our customers, they don't want any software. They want a solution for their problems. It just happened to us that the solution that we deliver is in the form of software. The architecture is usually a theoretical part. After long discussions with customers, with event storming, we have something in mind. We can draw this on paper, on whiteboard, but at the end of the day, the code which will be executed will deliver the final solution to the customer. And organization of the code is a crucial part in delivering a proper solution. Project structure usually influences performance of the future product, and it basically defines the entire life cycle of the product. Sometimes we see project structures which lead to a disaster, where code is organized according to some functions, rather functions of the classes, and not according to models that we define in the final product. So, okay, what is our goal? Let's create a very simple, extremely simple, primitive online bookstore application. Yeah, just before getting to the nitty-gritty of the domain-driven project structure, I would like to tell something about the credits, how I came up with the idea of this project structure. So I have a little bit of different sources. It's experience developing of hundreds of applications over my experience, my entire career. Then very nice here in this presentation, which I will share after the session. You can click on the links. I cannot pronounce the name of this guy. I never met him, but I read his articles, and I was terrified to see that not only myself came up with the idea of domain-driven project structure, but also, I guess, Wojciech Krivich, maybe this is the right pronunciation of his name. He also has written several articles dealing with this topic. And Alina Liburkina, it was my pleasure working with her, and we have discussed a lot different project structures. So let's start coding. Okay, now I will share my IntelliJ. So what we see here, basically we start with a very simple application where we would like to implement a bookstore. I don't have a silver bullet solution, but what I do have, I have a lot of recipes for disaster. Let's say that this is a Spring Boot project that if we look inside, we can recognize controllers, repositories, services, but in order to find classes that implement our use cases, we have to drill inside all packages. And with all this very simple application here, we already have some problems. So we don't know where to start. Let's say that we have here very simple Spring Boot application. We can even start this application. So it starts and runs, and in my project, I usually have something where I use very simple HTTP requests just to work from within same ID, not jumping to Postman or stuff like this. And here, if we go into actuator, so we are getting the response from our application, and we know that the application is up and running. So, hooray! But now, with the do you see it? So, should I make the font bigger? If so, please comment. So, this is the main package here. And then we have services, right? Repositories, books repository, controllers. If we start with a controller, this is the incoming port for our application. We see that the class, which is DTO, data transfer object, is defined in the same package as controller, and it goes through the entire application. So basically, we have something like a service which resides in the package service, or services in this case. It is also using the book DTO here, and this book DTO is going down to the repository. Well, here the repository is implemented in a very, very primitive way, so we are not going to any database. But the problem with this structure is that it only describes the functions of classes, and it violates all principles of normal software development. And we don't see anything which resembles as software architecture which was developed in order to implement ideas which we elaborated during, for example, event storming. Right. Okay. We understand that with this type of project structure, we are not going to develop any maintainable software. The unit testing here is horrible because all classes will depend on something which resides in infrastructure packages. They are not isolated, and they don't express any intention. Let's try step by step and elaborate something better. So I created a repository on GitHub, which I will make public after this session. And the branches are constructed in a very simple way. They're numbered, so you have branch like this, 0-1 recipe for disaster, and we have branches which start with 2, and we have domain-centric architecture. Okay, what we have here? We're back to our backstore package, and here we see that the bookstore application is divided into 3 parts. The main part is called application, and application contains all necessary configuration classes which configure the application. So this is actually has nothing to do with the solution domain for our customers. So customers are not aware of the configuration of the system. And here, web configuration, in our case, just defines the port for our web service. Then we have domain with one use case and core for this use case. This use case is a catalog. So we would like to display books available in our store, to make them available for the customers. And here we have the first domain class, which is a domain entity. And as you see, this is a very simple class, and it has no dependencies on either infrastructure or application configuration. The next package is infrastructure. In infrastructure, at this level, we will put everything which is required for our application as an infrastructure. Again, this package here will contain all necessary classes that have nothing to do with the solution domain. So what we put here is the first package. The first class is database health indicator. It is very important that our application publishes some information about the state of the application. It is important for example, for deployment of this application in OpenShift containers. But our customer is not aware of this. And this topic wasn't discussed in the domain modeling stage. Okay, I will relaunch the application. And let's go back to our integration. So our integration, we can again rerun and see that our application publishes already database state as well. So here are the endpoints which are exposed by our application here. What else we have here? We have also in resources, application properties. And this time we modified a little bit the repositories. So we created a very simple SQL schema. I'll make it bigger so we can see everything. So we will create a table for books to accommodate them with ID, title, author, ISBN, price, and quantity. And we'll put some basic data at the beginning. Right. Okay, so we created a very basic scaffold for our application. The structure is here, and hopefully the structure resembles for you what is usually defined in hexagonal architecture. So we have the core, the domain, and this domain will be addressed by the application, and it will communicate with infrastructure. So I'm getting the next. Oops, sorry. The core. So now we see how our application is getting more details. Where do we usually start? We start with the domain. So now I changed the names of the packages, and now we have application, domain, and infrastructure at the very top of the project structure. And here we discussing actually the application itself, the infrastructures that we need for the application with database health indicator, and we are getting another package, which is the domain. In the domain package, we will implement different use cases. We will put here a probably different bounded context. So in our core, we have a model which resides in the middle of the package with several ports. Ports are incoming and outgoing ports. Why do we start with the model? The model, so I'm going every step back to the domain-driven design. In our design, in the discussion with our customers, we have identified main domain entities. And the most important domain entity in our case is the book. So here we can create a class. In this case, it's just a record for books. And as you see here, in previous step, the book was a simple class with a lot of primitives. Author and ISBN, they were just strings. Now they have elaborated to author, which another class, and ISBN, another class. They yet only records, but we will see where we will end up with the further development of the application. In normal life, it's not only the happy path, but sometimes it may happen that the book we are looking for in our catalog won't be available. For these, we can define exceptions, like book not found exception. And this exception is a checked exception because we would like to model the normal flow of events as our customers described us, as we elaborated the model in, let's say, event storming session. And then the books will be accessed in the catalog use case using interfaces. The interfaces have several methods. The methods, again, describe the needs of our customers. They would like to display all books that we have in the catalog, or to find a book by its ISBN. So we are not talking about finding books by their ID as they stored in the database. For our customers, the book ID is irrelevant. It doesn't exist in their model. They're just talking about ISBNs. Maybe they would like to find by titles or a list of books based on the author. And currently, all these ports are defined in the same package as the main use case here, so in the core. This makes everything also testable. For example, the infrastructure classes, they are isolated from all the rest and can be easily tested or unit tested here. The data source that we are using currently, We can use either a database or we can use a file system as a data source, but it is not important at all at the stage of unit testing. Here we can just mock our data source. All right. So we successfully converted in the first stage the domain-driven model into a domain package on our side. And we already prepared everything necessary to communicate with our domain objects. Now we can go to the next stage. And we are going to implement the use case. So I close all the editors here. All right, what does it mean implementing a use case? Again, we can go into domain package. In the domain package, we see the use case that we are implementing currently. It's catalog. In the domain, now we have more packages, and it resembles the uppermost structure. So here we have the application, domain, and infrastructure. Now for the use case, we have again our core, which is the core of the domain. In the core, we have our model with the book, ISBN, author, and exceptions. We define the interfaces to communicate with our model. Oops. And we have a very first use case. This is catalog. Catalog is a use case which implements our definition from the catalog interface. In order to successfully communicate with our books, we need something which holds the records of the books. And this is book repository. Book repository, again, it's an outgoing port, and it still resides inside the domain package. But its implementation will be done in infrastructure. So coming back to the use case, so basically here in the use case, which is implemented inside the domain and is written in such a way that even non-software software developers can read this code. It is very easy. It's a catalog, and catalog, what it does, it displays all books or finds a book by ISBN. The implementation details, the actual infrastructure and the actual database is entirely abstracted away and hidden in another package. So our domain doesn't depend on infrastructure. In such a way, when we program using this paradigm, I will just for a second delete this annotation, and we immediately see that we don't have any implementation for book repository, because it's just an interface and it depends on the infrastructure. Oops, the proper infrastructure. Right. So to this end, what we can do, we are forced basically by our structure to implement step by step all necessary classes. In this case, we will write an adapter for book repository. This is a class which implements our book repository interface. Currently, we are not interested in the actual database, so we just write unsupported exception here. But for book repository adapter, we can already write unit tests. And our use case can be also unit tested because everything that we inject here, we can either mock or we can create some instances for in test classes themselves. So I repeat again what we created here. Our application looks like this. So we have our application, which is the product. We can configure our application. We can communicate with some deployment infrastructure. And here lives our business logic. And business logic lives in the package domain. The first use case is catalog, which is in the package domain. For catalog, we have our model with some interfaces and infrastructure. So let's go to the next step. So every time I open the project, I know exactly where to look for my use cases. So I don't need to look inside the application folder or in infrastructure package. I know that everything resides in my domain package. And here, now we created another package, which is called application. Okay, this may cause a little bit of confusion. Application, we have application twice, right? This application here is the entire product application. You can argue that we can rename this package for something different, but I haven't found any better term as application because infrastructure is already in use. Here is the core, and here the application. What do we have in our application? Right, we have our controller. So, and controller will be placed where we put our use case. But have a look. Here is use case doesn't know anything about the context where it will be used for. Our controller uses just this interface, which is implemented by catalog facade. Right, so currently we have something which can actually work. So we have means to communicate with our application. As soon as we start the application, we exposed another endpoint. So we have books, and let's try to run it like this. All right, we are getting 500. Of course, 500 is something that we would expect because at the current stage, we are going down to the infrastructure, and our repository throws unsupported operation exception. But we have a little bit more already in the package that decorates our controller. So the controller itself knows quite a lot. From one side to execute the use case, and it knows also quite a lot about what the customer expects from us or the consumer of our API. So it uses something which is called catalog presenter. Catalog presenter resides in the same package as the application. Because this is the class which is responsible with communication with the outer world. So it actually presents what we defined as the API. And it requires something more. So it knows that from the our core, it can expect our domain entities, books. But the communication through API uses book data transfer objects. They basically very primitive classes that are built on top of entity classes. For this, in every presenter, we have a mapper. So controller knows about use cases, about interfaces. He knows about presenter because this is his job to communicate with consumers. So it provides the interface, and it provides DTOs which are mapped from the domain entities. What is very important here, our core, our domain, remains independent of application layer or infrastructure layer. It provides interfaces that can be used by the application, and the implementation of the interfaces are used with dependency injection. What we created, in this step, we created more objects, but objects are still very much testable. And here you see that, you can see that we can test use case for all scenarios without dependency on any classes from the infrastructure or application layer. So let's go to the next step. So far, we created very interesting application which crashes on every request. So as a next step, we will implement the actual database. The database will reside inside the infrastructure package. So I'm going back to the model because our system is domain-centric. So we have our catalog facade, and it has book repository inside, which is an interface. And book repository is implemented within book repository adapter. Book repository adapter is just a glue code between the infrastructure and the core, the domain. What it needs the actual database. It needs this database in order to perform real-world operations, to retrieve or persist objects. So here we are using here Hibernate interfaces. But you see again another package with the same name model. So basically model you see at every 3 levels. Here the model in the domain is the main model or business logic model, where we're modeling our use cases. In the application, we are modeling the communication with API consumers. And in the infrastructure, we are modeling database entities. It is very pity that we are using same word, which is overloaded. Entity. We have domain entities, which first-class members in the domain package, and we have database entities. And here you see kind of a strange notation with PO. PO stands here for persistence object. Well, we can argue whether it's a good name or not, one mapping too far or not. But this is kind of a symmetrical solution. With communication with the outer world, we're using DTO, data transfer object. And here I came up with a definition of persistence object. And here we're using again primitives with annotations, with Hibernate annotations. So it's a database entity. So basically what we need another mapper, which is book entity mapper. Yeah, I could write book database entity, but I think book entity in the infrastructure package is quite an appropriate name. So basically, what do we do? Whenever we would like to persist an object or to retrieve it from the database, we need to map from the domain entity into a database entity or in another direction. And our adapter then can, make it a bit bigger so we can read it. So what we can do, we can find all, then we stream. This is coming from the database, the Hibernate implementation in this case. Then we map with an entity mapper from persistence objects into domain entity objects, and we return normal books. Again, we created book repository adapter class, which can be easily unit tested without any dependencies. And when we navigate back to the model, to the use case, we don't have any dependencies on infrastructure or on the application. let's try to run the application right now. Now it's supposed to work, I hope. And this is what we are getting back. So if you need any recommendations for domain-driven design books, they're already embedded in this project. So when you try to list all of them, all books, you will get recommendations. Yeah, and what we achieved here, basically we achieved quite a lot. If we compare our model, this is the book, which has authors, titles, and ISBNs, with the database structure, which contains much more information. So we have something like price and quantity. This information is currently irrelevant for our use case. That's why we need a mapper. A mapper in the infrastructure level here wrong mapper, wrong infrastructure. So this object here, which resides in the model of infrastructure book PO persistence object, defines just a subset of fields that we have in the database. It defines only fields that we need in our use case. For other use cases, we will create here in the domain package another package. Let's say that we would like to see not only the catalog but inventory. And in inventory package, we'll have a different model where books will probably have the same information as we have in this model. But additional to that, we will have quantity, or maybe quantity and the price. But let's go one step further. Okay, what do we have now here? Now we implemented another use case. So it was relatively easy to add more functionality to our application. Initially, we implemented just catalog for getting all the books in the catalog. But now, when we have book with a specific ISBN, or we have just a specific ISBN at hand, we would like to have more information on this book. How do we do that? So we go into our core. The model, we don't need to change it. It already supports all the necessary information. Kind of strange. Yeah, if something can go wrong, it will go wrong. So what we need to add in our model, another exception. And this exception is book not found exception. Yeah, just a second, we will set up the proper SDK. Sorry for that, but this is the penalty that I was ready to pay for a live coding session. Cradle. I probably need to restart IntelliJ for a second. Okay. Okay, we are back on track, I think. When compiles and runs. Okay, so here I would like to demonstrate how easy it is to add more functionality to the application. So we don't need to modify anything in the model. We just added some exceptions. Whenever we would like to retrieve the entire list of all books from the catalog, basically, we don't expect any problems. Maybe technical problems, database is not available. But from the business perspective, we either have the books or we don't have them. When we are looking for a specific book or for a book with a specific ISBN, it may be that we don't have this book in the catalog. That's why we introduced book not found exception and how it will be handled. In our ports, the outgoing port, book repository, has fetch by ISBN. And then the infrastructure, and you see that book fetched by ISBN returns an optional book. So what we have here, we have in our model, in our adapter, also optional book, which fetches from the database. And we don't have the book in the repository, we just give optional empty. Now, the catalog, when we fetch by ISBN, it throws book not found exception because this is business exception. The implementation looks like this. Book repository, when it fetches a book, when it doesn't exist, then exception is thrown. How does application behave? In the controller, we have just another mapping with ISBN. And here we have several interesting things. First of all, the exceptions that we are throwing, book not found exception, will result in an HTTP status not found. So we will be giving 404. Let's try it out. So okay, it's a small trick here. I'm just getting all the books, and from the third book from the list, I'm recording its ISBN and getting these details for this book. Yeah, everything worked very nice. But what happens when I give in something which for sure doesn't exist in the catalog? And here we are getting 404. But now ISBN is not just a simple string. So ISBN it's something is very well defined. That's why we would like to improve our application and give more feedback for our customers. Let's say that they do something like this with a wrongly formatted ISBN. So we would like to give them 400. How do we do this? This is probably another feature which you will get after deploying the version 1.0 to the customer. They say, okay, whenever I provide a wrong ISBN, malformatted ISBN, I would like to get a dedicated response, not just the book not found. Well, this change is rather simple with this structure. First of all, we are going and we are modifying our ISBN in the model. So we don't want any anemic entity classes anymore. So our ISBN has a little bit more knowledge about itself. It does also the validation. So we define the valid ISBN pattern, and whenever we map from either DTO or from a PO, persistent object, we go through the validation. In this case, it's guard process. So let's jump back to our controller and have a look here. ISBN is provided as a pass variable. And now, before calling catalog to find ISBN, we are doing something like this. So we are getting the builder instance of ISBN entity, domain entity class. And we are building it with this ISBN. And here, at this stage, we have something which guards the IDN from wrong formats. First of all, we look that the ISBN is indeed provided and it's not empty or not blank. And then we do pattern validation. So we can also distinguish between two different problems, but currently we keep everything simple and we just give the invalid ISBN format exception, which is caught immediately in the controller, and we giving batch request to the customer. So just to summarize what we have here. Starting with a very nice domain model provided by software architects, we created a very easy to understand project structure. The project structure actually displays all the layers in the applications that we have. This is the high-level structure, application, domain, and infrastructure. And the domain packages, they again describe the model, defining the boundary of the model, or you can call this bounded context. They define how we communicate with the consumers of our API, and we define how we communicate with the infrastructure. Everything is easily maintainable, unit testable, and testable. And what is very important, if I need to introduce more features, then it's very easy to navigate in this project. So I don't have to remember anything. I see this is my use case catalog. In my use case, I have my domain model, I have ports, the interaction, and I have infrastructure. All right, so this is very interesting subject, and I could even more elaborate with this project, and I could create more use cases. But unfortunately, I have only 64 minutes, and now I'm open for questions, and I hope I will provide you with answers.
Yes, 64 minutes. Thank you very much. It was a great session. It was a great live coding with a lot of examples. Yeah, what I especially like that how you made this evolution, namely where you start with the bad examples, right, with the disaster, and after that by using it and adding more code, you improve the readability of the code base. I think it. I mean, Uncle Bob, Robert C. Martin has a name for it, or pretty much related to the same thing. It's called screaming architecture, right? So when you look at, if it's not strictly related, but when you look at an architecture, or when you look at the folder structure of your code base, then it should scream the domain and not the underlying technology. So yeah. We had plenty of questions, and we had also very interesting conversations among our members. So let me start to read out what they were talking about, and after that, I'm interested in your take on it. Let's start it. So they were discussing about the IDs, and let's bring it on. So here we have, starting with Ilya, if the ID is not part of the use case and the domain, why it should be present in the database? Why not use ESBN as primary key without auto-incremented field at all? Let me continue. Here there was from David an answer. I think ESBN is a value object in this example. After that, Adam had some controversial idea or opinion about this. I mean, business value should not be used as internal IDs and stuff. Business changes, and if we use ISBN as an ID in the DB and put the unique constraint on it, and when business changes requirements, we are in a bad place. And also another additional thing, what he said. So resource identifier should not be used as a business value. You can use a business value to search for a resource, though. And here Ilya had an answer to this. If the business rule change, it's okay that you need to adjust your code and DB. Why not? So yeah, I would say, what is your take on this, Igor? Can we use such an ID as a business value or not? Or what is your experience on this?
Right. Okay. So first of all, I usually separate data between use cases. They shouldn't share use cases, data or data models. And I won't use ISBN as primary ID. Yeah, whether it's a value object or it's a domain entity, and I have just one aggregate rule, which is book, and book has many other domain entities like author and ISBN. So we can discuss, and there is no ground truth. It depends on your use case and how you implement your project. I actually prefer to separate data. So in my case, the ID in the database, it's something that I'm using to retrieve persistence objects. And ISBN, it's something which is used in the problem domain, because our customers should know about any IDs. If I store my records I don't know, if I print them on a piece of paper and then I scan them back in order to deserialize, our customers don't care. Well, because they want to have a catalog where they can retrieve object based on something that's well known for them in their problem domain, ISBN. That's it. Everything else is just implementation detail.
Right. Yep. What?
Yeah, I also have a comment here. I thought that it was a very interesting discussion. I also like to keep them separate. So even if the business says they are unique, and that's fine, I accept they are unique. But there could also be points like, let's say, database performance. For example, those ISBNs, they are strings. And that's fine as a business identifier, but let's say from a database design perspective, I don't think I would be choosing strings as my primary key identifier, simply due to, let's say, performance reasons, indexing or something like that. But instead have always another identifier and just put these ones as, how shall I say, a unique indexed field, as, but not as primary key.
Right. And books may have many ISBNs. Yeah, this can come later. Yeah, when we start with modeling such a store, let's say that this is a very rather small company operating in a very specific country, having a 13-digit ISBN. But as they grow and expand, they go to different markets, and suddenly they have different formats and many ISBNs. If I would have defined ISBN as a unique key in my model, I would have to rewrite my application from scratch with very painful and very expensive data migration.
Good points. The only constant is the change, right? So,
yeah.
Yeah, I would say it was a great answer, and I think things are cleared up. Let's jump on to the next one from Gabriel. He says, "How about?" So I think he or she made this comment when you were creating some record objects in Java. How about more complex entities? Because what is the reason to use record classes in the domain-centric structure?
Right. Okay. I think this question was asked before going to the last part.
Yeah.
I used records in the beginning just to show how the system evolves. The records are representing actually very anemic domain entities, which I don't like at all. And then from records with primitives, we went to more complex classes, like aggregate root, book as an aggregate root, having other entities like author and ISBN. And then ISBN got also validator inside. And we will also implement some business rules inside aggregate roots. For example, our book will have possibility to compute a price probably or quantity in a different use case within a different bounded context. Currently, books are just entities of the catalog. As soon as we are moving to a different bounded context like inventory, then the quantity of books is very important. And they can calculate quantities, they can reduce quantities or increase if we as a supplier buy more books from publishers, or we sell books to our customers. So records here are just very simple example in the beginning, just to emphasize how the project can evolve.
Evolutionary design, exactly. All right. Yeah.
I hope
Thank
I
you very much.
answered this question.
Yeah, absolutely. Thank you. I think you did very well. Thanks a lot. If nothing more to add, then let's jump on to the next one from Adam. Why not having the same method reside inside the persistent object? Is making DTOs and POs able to convert to and from dominant entity, just getting rid of mapper classes a good idea? What do you think, Adam?
Well, it's a very interesting question. So I don't have very strong opinion here. Having some mappers helps us to separate concerns. Yeah, I have my persistence object. It's just a model, just a very simple value object.
Mhm.
Why should it know about domain entities? This is the actually concern of a mapper. And mappers we can replace at any time, because mappers, they map to domain entities. And if we would like to store our domain object in a different way, in a different database, then we can use just different mappers with different entity objects. Let's say here I'm using relational database. If I switch to MongoDB, I just replace the mapper and use a different entity.
Yes, all right.
Yeah, I think there's just one part of this question. And the second one,
Yeah.
I won't share mappers between DTOs and POs. They are two different animals. So with DTOs, we communicate with consumer of our API, and we can change them at any given time. Let's say that we upgrade our API or change it from version 1 to version 2 without touching anything in infrastructure layer, in persistence layer, or in the domain layer. I can change my mapper and change DTOs. They are independent.
Mm-hmm. All right. Let's jump into the next one of the same person, Adam. It is a simpler question. I think you already answered this, but maybe we can talk about it briefly. So is the repo of what Igor is showing here on GitHub? I missed that. And I heard that you are planning to upload it, right, Igor?
It is a GitHub repo. It is currently private, but at the end of the session, I will make it public. And I will also post the link to it.
Perfect. Maybe you can also send it to us, so we can also include it in a YouTube description if you send it to us afterwards, so everyone can find it there. Surely that's also an easy way to share. Very good. Thank you.
I will do, and a little bit more on the repo. In this repo, you have everything you need, also the presentation. Despite it's very short, it is included there, and the HTTP files. This is a Gradle project, so basically you can just check out and ready you go.
Excellent. Let's go for the next one then. It's from Christina. Thanks a lot. When you have to access a third-party service such as SAP, would you store it also into infrastructure or into additional package?
Oh, it's not a simple answer for this. It will be spread across different packages. First of all, I will have a repository stored. Well, it depends what I need for SAP, but I need some sort of information in my business logic. So it will be abstracted with a repository where I will create an interface in outgoing ports. And then in the infrastructure, I will create an adapter, and I will use the actual connector inside the adapter. Just very much similar to what is implemented with a database, with a JPA database. This is quite a universal pattern. So it doesn't matter whether, again, back to my example, if I, instead of storing in the database, I will print out, so I can use here print function, and then as input I can scan and use OCR. It doesn't matter. So you can put here whatever you want. This is an abstraction on actual physical infrastructure.
All right. Very good. Thank you very much. Yeah, let's go on to the next one. We still have people were really interested. They had a lot of questions, as we expected in the beginning. Let's see. From Donny, what's the reason for returning a specific DTO from the presenter instead of giving the implementation of the presenter full control in the adapters layer? Feels like an unnecessary abstraction at the moment.
Well, you can. This is the same as for mappers. So the presenters, they can actually do much more than in this example. In this example, I'm giving back some HTTP codes for 00404. This we can do from the presenter. And this is kind of part of a mixture between business logic and the API that we are providing. Our business logic defines all the happy and sad passes. And so the presenter is just the way to present our information to one of the consumers. Think about a different scenario that we have many different consumers. So they might have different way of data representation. And then and I can configure my application in such a way that I will instantiate different presenters. And some of them will give very extended explanation why we're giving 404, why we're giving 400, or maybe some of them will require authorization. Yeah, for example, I can imagine that one author would like to get a list of his books, only his books, and then modify, extend the catalog with his newly published book. So he needs authorization for this. And the presenter for him will give him, wrong password or something like this, or you cannot access this resource.
Thank you very much. So again, a very good and detailed question. You are very good at answering, as far as I can judge. We don't have more questions, but I have one. I would like to know what is your experience on how do you introduce this? So let's say you have a company where there is a code base, there is a legacy code base. So how would you introduce this domain-driven project structure there? How many time would you sort of estimate to change an existing code base? How would you approach this topic when you are, for example, hired by a company to change their, to improve their software?
Yeah, well, it depends, So for this question, I'm just back to very famous saying that our customers are not looking for any software; they are looking for solutions. And right, so, and if I have a well-working project which is structured like in my very first example, which is a recipe for disaster, but there are no perspective for future development. No one would like to fix any bugs. I won't touch this project.
Mm-hmm.
If you have something that should be done quick and dirty, maybe I won't insist of doing such a thing because it has quite a big overhead. with mappers, with everything. Yeah, it pays off for long-term development because we create testable code and maintainable code. But if you need something to do very fast, frankly saying, you can do this without any structure. You can do this with willy-nilly architecture. Yeah. So, and if you do this for a big legacy project, you can expect also very tough resistance. So you need to do this incrementally with a lot of patience.
Exactly, it's a sort of tech debt, right? So we sort of following the Boy Scout rule, we leave the code base a better place behind, and we keep improving it. We always dedicate or spend, or every time when we touch a part of the code base, we improve it or leave it in a better place.
Right. But we just left the methodology and we step into organizational problems.
Absolutely, exactly. Yeah, exactly. I was just interested in this, but great answer. I think we have Donny had an answer to, I think, what you were talking about. Maybe we can show it. We can go through it, and we are interested in your remarks. So he says. So again, he asked the previous question just to put in context about this, And after that, no, he says this. Right, but from my understanding, the presenter turns it into a push architecture. So instead of returning a specific type, you can directly communicate with your delivery mechanism. He still have two more. For example, I could implement a presenter in the adapters layer that gets the response object injected. No, it's able to send the response from the presenter, where your presenter returns directly from the use case, so pool, which is the same as mapping to me.
So in my use case, there is no place for presenters because use cases live in the domain package. So they don't know how we communicate with the outer world. So the presenters are in the application layer, in the application package. Right? Presenters, they do know or they depend on DTOs. The use cases, they don't know anything about DTOs. We had DTOs in the very first example where DTOs were everywhere. So basically our business logic was dependent on infrastructure, which is a horrible scenario, right? It's a disaster, actually. So,
all right. I think it was well answered. If he has any other remark, then we can get back to this. Jumping back to the topic, we had a good remark from Garrick West about that ID. You remember we talked in the beginning, this ISBN and whether to use it as an ID or not. And this is what he answered. I'm interested what you think of it. Garrick West, by the way, welcome. It's good to see you here. So Garrick said, the best argument for unique IDs is this. It's cheap and easy. The alternative is trusting so-called business experts to be right about uniqueness. I will just generate. Thank you.
Yeah, we're pretty much aligned.
Exactly, easy and cheap, and we could prevent a lot of rework from the future.
Just another comment on this. We have to trust business experts. Without business experts, we cannot build business logic. But we have to make our software architecture also maintainable and open for changes. So if at this given point, ISBN is a unique identifier of a book or of an item, it doesn't mean that it will stay forever like this. That's why we can find books with ISBN, but we shouldn't rely on them in our persistence infrastructure.
Very good, thank you. Maybe another question from my side. So, I think you refer to this, the hexagonal architecture, ports, adapters, etc. Have you ever used this project, based for the structure outside hexagonal, or you always use with the hexagonal architecture, or how do they correlate with? I mean, what is your experience? How do you handle this?
Yeah, this project structure very much resembles the hexagonal architecture.
Yeah.
But actually, I use this with a mixed architecture. So sometimes, these things are out of your control. So also, I'm using ports and adapters, but still you can use this with layered architecture, just to rename them a little bit.
Mm-hmm.
At the end of the day, you just have the separation of different layers. Yeah.
Mm-hmm.
I can call them use cases. I can call them.
Yeah, definitely. Yeah, because let's say you have a very simple project, sometimes a hexagonal architecture might be an overkill. If you have a very simple and it will stay like that, of course, we can never say 100% sure that it will stay like that, right? But for simple projects, sometimes, less is more, but still, for the feature-based folder structure or domain-driven folder structure, we can gain a lot, namely to make our architecture more screaming. Getting back to Robert C. Martin's point, that it screams the domain, it screams about the domain, and when we look at it, we can tell what this software does instead of what this software is implemented with, right? So it's not like when I look at the application, I'm not interested if there are control layers or if it is .NET Core or MVC. I'm interested in the use cases, because by doing so we can, it also makes the onboarding easy based on my experience. So let's say when there is a new developer joining to the team, then the learning curve is much better, because when they look at it, they can relate themselves, they can mind map the features they are about to change and implement. So it also helps to onboard new developers. And another what is now coming to my mind is to the cohesion, right? I mean, it can help us to reach high cohesion, right? I mean, because we really group features or group files together into a folder which they belong to, right? To the feature, to the use case itself.
Absolutely, yeah. There is another aspect which we sometimes tend to disregard. So what is written in the domain package here, using very simple language, and language from the business perspective. So, and actually the classes are very simple. They are not very technical, and you can discuss them with business people.
Mm-hmm.
Yeah, just saying, okay, this is the business flow. Is it okay, or do you see any problems? Some cases that we've forgotten to implement. So I'm using this for so-called design qualification.
Mm-hmm.
It's very, very fast to write. And then before writing any integration tests and before delivering software to the customer and then figuring out that we've forgotten about something,
so true.
You just grab the business person and show him. And this reads like a story, which is actually a normal user story. Yeah, we call this use case, but this is a user story, and he reads, okay, we've forgotten this one here.
That's an excellent point. I can totally agree with that. I mean, we can get, by using this, we can get feedback from the customer as soon as possible, earlier than later, so we can react and we prevent expensive reworks. So yeah, I think it's an excellent remark, and I think it's a great way to end our sessions, because the time is over. Unfortunately, we have only half minute left. So Igor, it was a pleasure. Thank you very much for your presentation. I think we learned a lot. We also had a very active audience, so they were very interested about this topic. And also, I would like to say thank you to Valentina and Oliver, to co-organizers and co-hosts, and of course, thanks a lot to the audience. We were technical excellence, learn how to deliver quality software faster. As I mentioned, we are available on social media and a lot of platforms. You can reach us. And if you have any questions about tech excellence, just ping us on this platform. So again, thank you very much for everyone. And see you next time.